Hi, this is Swati. Welcome to the channel. This is the video on data handling, most important and repeated questions. So in my previous video, I've already explained you each and every topic of this chapter class 8. Go check that video and then look for this video. I'm very sure you will be able to do all the questions that we have here. Now let's get started. The first one is construct a frequency distribution table for the following marks obtained by 25 students in the history test of class 8. So here to construct a distribution table, we will first arrange the numbers. Let us write the numbers first. Maths, these are the marks, marks. The smaller number is 9. After, okay, we also have 7. Yes, we have 7. This is 17. I hope this is 17. Okay. After 9, we have 12. So, firstly, we will write all the numbers and then we will count the frequency. We will write the frequency. After 9, 12, and then we have 17, 18, 19, 20, and 25. I hope that is it. Yes. Then next up we have number of students, that is frequency. Okay, how many times 9 is appearing? 1, 2, 3, 4, 5, 6. So there are 6 9. So the frequency is 6. Frequency is basically how many times that particular observation is occurring. Next, 12. 1, 2, 3, 4. Yeah, 4. 17. 1, 2, 3, 4. Again 4. 18. 1, 2, 2. 19. 1, 2, 3, 4. Next is 20. 1, 2. 1, okay, 2, 3, 3. And then 25. 1, 2. So this is frequency. So if, in just in case if you're in doubt if you have done it right or wrong, it's always advisable to check your frequency count. So if I'm adding sum of all my frequency, I should be getting 25 because there are 25 students. 6 plus 4 10 plus 4 14 plus 2 16 plus 4 20 plus 5 25. So that means our frequency is right. Now, once we have created the frequency distribution table, here we also need to write the tally marks. So tally marks, I'm sure you know it. 6 means 1, 2, 3, 4, 5, 6. The 5 is the cross mark. 5 or the multiple of 5 is the cross mark. 4, 1, 2, 3, 4. Again 1, 2, 3, 4, 2, 1, 2, 3, 4, 1, 2, 3 and 1, 2. Now this is the frequency distribution table. Let's solve the questions. First one, the range. Range is what? Range is the highest number minus the lowest number. The highest number is 25 minus the lowest number is 9. 25 minus 9 is 16. Second, what is the highest mark? Here the highest mark is 25. Which mark is occurring more frequency? More frequency. What is the highest frequency? It is 6. And what is this 6 frequency for? It is for the number marks 9. That is it. So I hope this is very simple. Now moving on. In a hypothetical sample of 20 people, the amounts of money with them were found to be as follows. Draw the histogram of the frequency distribution taking one of the class intervals as 50 to 100. So here we have class intervals and we have frequency. So see, why are we considering class intervals? Because when we have a lot of data, writing each and everything becomes tedious and most of the students go wrong with that. So if you have intervals, it is much easier. So one of the class interval is 50 to 100. So if I start with 50 to 100, what is my highest? I can see my highest is 235. So let me just write the intervals after 100, then 100 to 150, and then 150 to 200, 200 to 250. Yes. Now, when I talk about the interval, let me take 50 to 100. So this is known as the lower limit and this is known as the upper limit. So when we have lower and upper, just in case if I have 50, so will 50 be counted in this one? And just in case I have 100. Okay. So yes, the lower limit is always calculated in the class interval. The lower limit is calculated, but the upper limit is not calculated in the class limit. So when I have 100, I will not be writing in this class interval. It will go to my next class interval, right? So when I have the intervals, only the lower limit will be counted in that, but the upper limit will be counted in the next class interval. So make sure you do it properly. Now let's start counting. 50 to 100. Do we see anything? Now see 100. I'm not going to count 100 in this interval. 100 will be counted in my next interval because upper limits are not calculated. Only the lower limits are counted. So 50 to 100, I can just see there is just one number, that is 98. Okay. 100 to 150. There are so many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There are 12 numbers. Next, 150 to 200. 150 to 200 is 1, 2, 3, 4, yeah, 4. And 200 to 250, I can see 1, 2, 3. Right? In case you are in doubt, I'm again telling you, please add up all the frequency. I need to be getting 20, which I'm getting. So that means it is right. Now, drawing the histogram. So first, let us make the axis, x-axis and y-axis. So on the x-axis, we always write the intervals. On the x-axis, we write the class intervals. So it is starting from 50, 100, 150, 200 and 250. In bar graphs, you have spacing between each rectangles, unlike in histogram. In histogram, there is no spacing between the rectangles. You will draw the rectangles, the width of the rectangle should be uniform throughout, but there is no spacing in the histogram. There is just this one difference between bar and histogram. Now, 50 to 100. Okay, these are the frequency. On the y-axis, you always write the frequency. In bar graph, histogram, line graph, all the graphs, y-axis is frequency. Now, I can take maybe the difference of 2, 2, 4, 6, 8, 10 and 12. Now, 50 to 100 is 1. Okay, 50 to 100. 50 to 100 is 1. Next, 100 to 150 is 12. So it is here. Yes. 150 to 200 is 4. So 4 is over here. So see, there is no spacing between them, and these width of the rectangle should be uniform throughout. 200 to 250 is 3, little less than 4. Yes, this is the histogram. This is just a rough look, but I hope this is clear how to construct a histogram. On the x-axis, you have the class intervals, and on the y-axis, you have the frequency. And when you're talking about the class intervals, the lower limit is counted, but the upper limit is not counted. It will be counted in the next interval. Next, moving on to the next one, a die is thrown. Find the probability of getting these. Now, firstly, what are the outcomes when a die is thrown? So, let us write the total outcomes. What are the total outcomes when the die is thrown? 1, 2, 3, 4, 5, 6. A prime number. So, first is a prime number. What are the prime numbers here? We know 1 is neither prime nor composite. So it starts with 2, 3 and 5. There are 3 prime numbers. So if I want the probability of this event, probability is what? Favorable outcomes. I'm not writing the formula. Favorable outcomes. So how many favorable outcomes? There are 3 favorable outcomes divided by total outcomes. There are 6. So which is 1 by 2. Always you will write it in the reduced form, and probability you can just leave it in the fraction form. You need not convert into the decimal form. And you are also aware that probability always lies between 0 and 1. Never less than 1, never more than 1. It can be 1, yes. It can be 0, yes. Second bit, 2 or 4. So 2 or 4, whenever you have or, that means you're going to add both of them. So probability of this event is probability of getting a 2 or a 4. So there are 2 favorable outcomes divided by total outcomes is again 6. So which is 1 by 3. A multiple of 2 or a 6. Multiple of 2. What are the multiples of 2? 2, 4, 6. And what are the multiples of 3? 3 and 6. So what are the favorable outcomes? Or, I just told you, whenever you have or, you will add all the outcomes. So 1, 2, 3, 4. You won't repeat the same thing, right? 6 won't be counted twice. It will be counted only once. So the favorable outcomes are 4. By the total outcome is 6. So 2 2s, 2 3s. The answer is 2 by 3. Now, next one. Now, before moving to the next question, I will first give you an overview of the cards quickly. As in my previous video, I have already explained you the complete, overview of the 52 cards, but I'll just recap it. So as you know, the well shuffled deck of cards, you have 52 cards. So out of which you have 26 red cards and you have 26 black cards, right? In red, again you have two segments. You have hearts and diamonds. Each are 13 each, isn't it? Similarly, in black you have spades and clubs. Again, each cards are 13, right? So let me just draw the picture. Hearts, diamonds, spades and club is a tree. All right. Now, what are these 13 cards? These 13 cards are 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King and Ace. So this is basically J, Q and K. These three are known as the face cards. Why face cards? Because you have faces on these cards. Now, if I ask you how many face cards do you have in these 52 cards? So each suit has 3 face cards, right? Jack, Queen, King. So 3 plus 3 plus 3 plus 3. So there are altogether 12 face cards. I hope this is clear. So how many red? 26. How many black? 26. So in red you have 13, 13 of two parts, and similarly in black. So what are these 13 cards? These are your 13 cards that you need to know. So this is it, and now let us solve one question on this cards. A card is drawn at random from a pack of 52 cards. Find the probability that the card drawn is a black king. So probability, since you're finding a probability, the denominator is always total number of cards 52. Now, king, how many kings do you have? In each suit you have one king, right? So you have 4 suits, so 4 kings. But they are asking for black king. So in black you have 2 kings. So the probability is going to be 2 by 52, which is 1 by 26. Next, either a black card or a king. Now this is interesting. Either a black card. How many? I told you, or means we always add. Okay. Now, how many black cards do we have? Black cards we have 26 altogether. And how many king do we have? We have 4 kings, right? But in these 4 kings you have 2 red kings and 2 black kings. But those 2 black kings are already counted in this, so -2. So the total favorable outcomes will be 28. I hope this is clear. Black card, which is 26, or a king. Kings are 4. But in these 4 kings, you have 2 red and 2 black, out of which 2 blacks are already counted in these 26. You cannot count it twice. So which is why I have subtracted 2. So 26 plus 2, 28. So probability is going to be 28 by 52. So if I simplify, uh, 4 sevens are 28, 4 13s are. So 7 by 13. I hope this is clear and not confusing. Next one. Black and a king. And a king. So what do you mean by and a king? And means the, the mutual. What is mutual in both? What is common in both? Black may, you have how many kings? It should be a black card and it should be a king. Firstly, you have 4 kings, out of which 2 are black, 2 are red. So you are only looking for black king, so which is 2. So probability is 2 by 52, again 1 by 26. Next, a jack, queen, or a king. So what are these jack, queen, king? These are all the face cards. So how many face cards do you have in set of 52? You have 12 face cards. Each suit has these 3 face cards, and you have 4 suits. So 4 into 3, 12 divided by 52, which is 4 3s are 12 and 4 13s are 52. Next one, neither a heart nor a king. Okay, neither a heart. So you will subtract. Neither means you will not include from a set of 52 cards minus neither a heart. So how many hearts do you have? Heart is one suit. Each suit has 13 cards. How many hearts you have? 13. Nor a king. It should not be a king as well. How many kings do we have? We have 4 kings, right? 4 kings, 2 red, 2 black. Out of which 1 king is already counted in the heart, right? I have removed hearts, 13 hearts. In this, there is 1 king which I have already removed. So remaining, how many kings do we have? 3 kings that needs to be removed. So again -3. So 52 minus 16, which is equal to 36. So probability is 36 by 52. So which is 4 9s are 36, 4 13s are 52. I hope this is clear and it's not confusing. Let me just explain you the last one again. Neither a heart. It should not be a heart. That means from a set of 52 cards, I have removed all the hearts that are 13. Nor a king. How many kings are there? There are 4 kings, out of which 1 king is there in this suit, heart suit. So which is already included. I will not remove it again. It's already included. Apart from that, there are remaining 3 kings which I need to remove. So -3 again. So yes, this is it. And the next last question for today is, the pie chart given in the figure represents the expenditure on different items in constructing a flat in Delhi. If the expenditure incurred on cement is rupees 1,12,500, find the following total cost of the flat. Now, how do we find the total cost? How do we write in the pie chart the central angle? How do we find the central angle? So we are given the central angles here. So the central angle, let me take the 75. Any central angle you can take. 75 divided by sum of all the angles is 360 into the total, which is equal to 112,500. This is how we do, right? So total will be equal to 112,500 into 360 by 75. So here you can reduce. Once you reduce it, once you calculate everything without wasting a time, I'm just writing the direct answer, which is 5,40,000. This is the total. Now, expenditure incurred on the labor. So which one is the labor? Labor is the purple one. So 100 divided by 360 into the total. We just found the total, which is 5,40,000. So this zero cut. 18 twos are 18 threes are 54 0 0 0. 2 ones are 2 50s are, so 5 into 3 1,15,000 is the expenditure. So this is it. So you just need to know the right formula of the pie chart, which I've already explained in my previous video. I hope you understood. I have covered each and every topic one question. So yeah, this is it. Please subscribe to the channel if you haven't subscribed it, and watch the next video, which is on the next chapter. Thank you.